The moving sofa problem is one of the most important unsolved problems in mathematics. Originally posed in 1966 by mathematician Leo Moser, the problem asks, what's the largest two-dimensional shape you can move through this L-shaped hallway that has a width of 1 unit? Well, let's start by moving the square sofa through the hallway. The square has an area of 1, but surely we can do better than this, right? Well, how about this semicircle that has a radius of 1? It has an area of approximately 1.57 and looks way cooler making its way through the hallway by rotating. But the first big leap in the moving sofa problem came about in 1968 when the mathematician John Hammersley introduced this shape to the hallway. The Hammersley sofa chops the semicircle in half, adds a rectangular block in the middle, and chops a littler semicircle out of the middle of the rectangular block. It has an area of approximately 2.2074 and kinda looks like a sofa or a telephone. And that's just really satisfying right there. The Hammersley sofa reigned supreme until 1994 when the mathematician Joseph Gerver introduced this beauty to the mathosphere. It actually looks pretty similar to the last Sofa King, but this sofa has 3 straight line segments and 15 different curved segments with various different curves on it. The Gerver sofa has an area of 2.2195, and would you look at that? Dang. There is some evidence that this is the largest possible sofa that can make it through the hallway, but it hasn't been proven mathematically. But all these sofas can only turn one direction down the hallway. If you had to turn the other way, you'd be screwed. Surprisingly, if you have to turn both ways, this shape is the least likely to get plugged up in the hallway. It was figured out in 2018 by Dan Romick, who was on Numberphile and whose website I got these animations from. So now, I'm sure that you'll agree that